Good morning, good afternoon, good evening, depending on when you're watching this. It's your boy Mr. Malaji, and you are tuned in to another video. And in this video, we'll be unpacking trig reduction. So we're gonna be building our knowledge all throughout the video. So stay with me, and in the next video, I will look specifically at reduction with special angles. So let's build this knowledge. So we have this cast diagram that we've looked at in the previous video. We know that all the ratios are positive in that quadrant, in the first quadrant. Only sine is positive in the second quadrant. Only 10 is positive in the third quadrant. And only cos is positive in the last quadrant, in the fourth quadrant. So if we wanted to reduce these things, what we need to understand is that if you're in this quadrant, you're in this quadrant because you are either 0 plus theta, right? 0 degrees plus theta would put you into this quadrant, or you're in this quadrant because you are at 360 plus theta will also put you in this quadrant, right? Then what puts you in the second quadrant? Second quadrant, you either going to be in the second quadrant because you are 180 minus theta, and then in the third quadrant it's going to be 180 plus theta, and in this last quadrant this will be your 360 minus theta. So I haven't spoken about the 90s and the 270 yet. We will get to those. Let's just work with the ones that we have right now. So whenever we see 360 plus theta, we know we're going to end up in quadrant number 1. So let's try reducing some of these, and let's look at examples of some of these. So example number 1, if this said sine 180 plus theta, then how would I reduce this? Again, the way you reduce this is you check which quadrant you're in. So this puts me in the T quadrant, and sine is negative in that quadrant, so this ends up being as a negative sine of theta. And there we go, as easy as that. Now let's take numbers 2. What if we're reducing something that looks like cos of 360 plus theta? So if we were reducing this, then it would put me in this quadrant, which is the first quadrant, and every ratio in that quadrant is positive, so this will just end up being a positive cos theta, and that will be my final answer, right? I hope you guys are seeing what's happening here. Let's just try maybe 2 more, and then we'll apply it to a real example. All right, what if we had 10 of 180 minus theta? So this 180 minus theta would put the 10 in the second quadrant, and 10 is negative in that quadrant, so this would make a negative 10 with a positive theta angle. So these are just simple reductions that you can apply to actually simplify your expression. So let's take an expression and let's try to apply these to simplify it. Alrighty, let's take this example here and try to simplify it. So we just need to reduce each component there. So cos 360 minus theta would put us in this quadrant here. So what is cos in that quadrant? Cos is positive in that quadrant. So this ends up being a positive cos that is being multiplied by a 10 180 minus theta. That will put it in this quadrant here, the S quadrant, and 10 is negative in there. So we get this negative 10. And this is all divided by a cos 180 minus, which will also make it a negative. So we have a negative cos theta And at this point, you can cancel the cos, and the negatives are also going to be cancelling. And so your final answer is just 10 theta. Let's try another example of these. All right, let's try this next one. So for this next one, we're given sine squared 360 360 minus theta. So where does that put us? It puts us in this last quadrant there. So it makes this sign a negative, but you have a negative that is squared like that. We'll come and evaluate that. That should be a positive. The cos 360 minus theta will put us in the last quadrant, but that is positive, so this will be a positive cos squared like that. And underneath, sine 180 plus theta would put me in this third quadrant here. And so what is sine there? Sine is negative. So we have a negative sine theta that is being multiplied by a positive sine theta because it puts us into that quadrant, and sine is positive in that quadrant. So we end up getting this. Let me just evaluate. The squaring of the top will give me a sine squared theta times a cos squared theta. They're both positives. And then at the bottom, I'll just have a negative sine squared theta. The sine and the sine are going to multiply to give me a sine squared theta. Then at this point, the sine squared and the sine squared thetas are going to cancel, leaving me with just the negative and the cos squared. So my final answer is a negative cos squared theta. And there we go. So at this point, I think you should be seeing how reduction works. I do want to add to this because there's some other laws or other rules that we need to know. And so let's move on to that part. All right, so another type of reduction that we need to be familiar with is how do we reduce negative angles? So for example, if this is theta, right? If this is the angle theta, then you going the opposite direction, or you going clockwise and measuring this angle, this will be the negative theta, right? So what does that mean? It means whenever we see a negative angle, it actually puts us into this quadrant here. So what are positives and what are negatives in that quadrant? The cos is positives, the sine and the tan is negative. So what does that mean? It means if I have a sine negative theta, that will stay as a negative ratio. If I have a tan negative theta, will put me in that quadrant, and since tan in that quadrant is negative, will stay as a negative tan ratio. But if I have a cos negative theta, then this will be a positive cos theta. So these are called negative angles. Right? So again, you need to be familiar with how you reduce for negative angles. Then furthermore, let's unpack how would we reduce if we had angles that were greater than 360. So for example, one thing you need to notice about 360 or anything greater than 360 is that if you reduce by adding 360, you're going back to the same point. You're taking a revolution, but you are ending back at the same quadrant. If you are, that's addition of 360, but if you're subtracting 360, you're moving in this direction, but you're also ending up at the same point. So This is a nice reduction to use, or this is a nice rule to use whenever we have something that looks like this. So now we have theta minus 180, and usually we always want to see it as number plus or minus theta. That's how we always want to see it, so it does not look like that. So what I could do is I could just add 360 in that bracket. So if I add 360, what it does, it gives me back to sine theta plus 180. And this, if I just rearrange it, it's 180 plus theta. And 180 plus theta puts sine in this quadrant. And so sine in that quadrant is negative. So yeah, adding or subtracting by 360 is a useful tool to use whenever you're doing these reductions. Let me show you another example where this is useful. Another example where this is useful is if we have sine of 450 plus theta. So clearly this is greater than 360. So instead I could reduce it by just subtracting 360 in that bracket. Let me just show the calculation of how do we get there. So this will be sine 540 minus 360, and I still have my plus theta there. And 540 minus 360 is just 180. So now that it looks like that, 180 plus puts sine in this quadrant, and sine in that quadrant is negative. So again, that is just a useful way of us reducing these by adding or subtracting by 360. And it always has to be 360 because 360 takes us into a full revolution, taking us back into the same quadrant. Or you could even use 720 because 720 is twice of 360. So 720 you'll be taking 2 circles or 2 revolutions, and you would still end up at the same point. So again, this is just a useful tool on how to reduce these guys. Then there's one last reduction that I do need to show you, and these are called cofunctions. So the one I'm gonna just talk about now is cofunctions, and I'll just give you the rule. I won't really show you where it comes from. I'll just give you the rule. So let's say we were reducing for 90 degrees, right? This quadrant would be the 90 degrees minus theta. This quadrant will be the 90 degrees plus theta. If we're doing it for 120, 270, this will be 270 minus theta. This will be 270 plus theta. But what happens with those guys, whenever you're reducing for 90 degrees, the sine changes into a cos, and the cos changes into a sine. So what do Mr. Malachi mean? I mean, for example, let's take this as an example. If I have sine 90 minus theta, then what the sine would do is it would change into a cos, and then since every ratio in that quadrant is positive, the sine, the cos that it changes into will also be a positive cos. So this is my final answer. Let's reduce some more of these so we can see what's happening there. What if we had a cos of 90 plus theta? So now we are taking it into this quadrant here, right? But I ask myself, what is cos in that quadrant? Cos in that quadrant is negative. So this cos changes into a sine, and it's now a negative sign. I hope you guys are seeing what the logic is there. Let me do more reductions of these so you can see more. What if we had number 3? What if we had cos of 270 minus theta? So this would put me in this quadrant, and cos in that quadrant is negative. And what I should never forget is that it changes into a sine. And let's do one last one, number 4, sine of 270 plus theta. Then for this one, I would know that it takes me into the last quadrant, but sine is negative in the last quadrant. So this becomes a negative cos with a positive theta angle. And there we go. So this is how these co-functions work. And I think at this point we've built enough knowledge to actually go and apply them onto some examples. So let's simplify some examples and let's see what we get. Alrighty, so let's simplify this expression here using our reduction. So we have sine theta minus 180. Remember, we always want to see an angle, well, 180 plus or minus theta. So this is not sitting the way we want it to sit. So instead, we're going to come into this bracket and add 360. And if we add 360, we'll end up with sine, and I'll just put the 180 first, 180 plus theta. And in the second quadrant, in the second guide, the cos, I will be subtracting 360 because the 540 is greater than 360. So I'll end up getting a cos 180 plus theta. And in this one, negative angles, we remember that it actually becomes a negative ratio. If it's sine and if it's tan, then here we have cos 180 minus, let's just do that one. It puts us in this quadrant, the S quadrant. And so what is cos there? Cos is negative in that quadrant. Just put them in brackets because all of these guys are multiplying. The last one, sine 180 plus, puts us in this T quadrant, but sine is negative in that quadrant. So it ends up looking like that with the squared outside. Let's reduce this guy, sine 180 plus, puts us in this quadrant, the T quadrant. So this becomes a negative. 180 plus theta puts us in the T quadrant, and cos is negative there as well. And we still have our negative sign, but we've reduced already. Here we have our negative cos that we've reduced already, and this, if you square it, you just get a positive sine squared theta. Then if we were to finish simplifying this, at this point we could just cancel what is the same. So I'm going to cancel the cos. I'm going to cancel the cos at the bottom. I have one sine there. I'm going to cancel it with one of the sines. I have the second sine there. I'm going to cancel it with that remaining sine. So what I'm left with is a negative that is timesing a negative that is timesing a negative. So I end up with a negative 1 at the top. And at the bottom, I also have a negative 1. And if you divide these, you get a positive 1 as your final answer. So I hope you see how all of this could come into play. Let's do one where there is some co-functions in there. All right, let's do the second example. So for this one, we clearly can see that the first one is not sitting the way we like it to sit. We always want to see a number plus or minus our theta. So in this case, what should be best to do is I would add a 360 there. If I add a 360, I end up with the cos, I'll put the 270 first, plus a theta. The second one, a negative angle for the cos will just give me a positive cos ratio. And then this guy, 360 minus, puts me in the last quadrant, and sine is negative in that quadrant. So we have a negative like that. Make sure you use brackets so that it's not a minus, it's instead a negative sign. Then this 180 plus theta just puts me in the t quadrant, and sine is negative in that quadrant. Then with the last one, theta minus 360, we don't like seeing it like that. So again, what am I going to do there? I'm going to just add 360 in that bracket. And so if I do add 360, I'm just left with the positive cos theta. Then let me reduce the other ones. 270 plus theta would put me in this quadrant here. But what is cos in that quadrant? Cos is positive, but remember 270 changes the guy into a sine. So I have a sine now. I have a cos theta there. I have a negative sine theta. And at the bottom, I have a negative sine theta with a cos theta. Then now I can start cancelling. I'm cancelling this whole negative sine theta with this whole negative sine theta. I'm cancelling these cos with that cos. And so my final answer for this guy will just be a positive sine theta. And there we go. So that's how reduction works. In the last question, I would like to take an exam type question, and let's look at how we unpack that. Have a look at this exam type question. So this was from Gauteng, a Gauteng paper 2 that was written in 2023. It was obviously grade 11, and this was a final paper written in November. So we asked to reduce this to a single ratio. So let's do that. Let's just remember what our cast says. All students. Alright, we have 0, we have 90 degrees, you have 180 degrees, we have 270 degrees, and we have a 360. Alright, so if it says 360 minus, it puts me in this quadrant there. And 10 is negative in that quadrant. So we have a negative 10 with the x. The next one, 90 plus, sine is positive in this quadrant. So it ends up being a cos with an x. Remember, if it's 90 or 270, it has to change. Then sine with a negative angle just becomes a negative ratio. And now that we have that, we need to just remember our identity. The one identity that you need to know at this point is that sine x over cos x is the same as 10x. So let's substitute that identity for 10. So I'm replacing what the 10 is with sine x over cos x. Still have every other thing the same, negative sine x. And then what I will notice is happening at this point is that this cos and this cos are multiplying each other, and so they cancel. And lastly, the sine here at the top and the sine here at the bottom also cancels. So I end up with a negative 1 that is dividing a negative 1. And that is a positive 1. So for 4 marks, you had to do this whole steps. and that's how you get to your final answer. And that's it from my side. Good luck with these type of questions. I will see you in the next video. Bye.